Welcome to the video lecture based on electric circuit theory, paper code ECE301. Today's topic is Introduction to Two-Port Network, and this total syllabus is based on Markov theory. So, Markov two-port network is another modulator of circuit theory. And this is the first lecture of two-port network. Myself, Kumru Banerjee, Assistant Professor of Electrical Engineering Department, Dr. Sudhir Mishra, Institute of Technology and Research Complex. This institute is formally known as Dr. Sudhir Mishra Degree Engineering College, and this institute is under JIST. In two-port network, we will basically learn about various types of two-port networks and where it is used and what are the parameters of two-port network that we will learn through this module. And what are the relationship between different two-port networks that we will also learn here. So this is the first module for two-port network. Here we will only understand about what are the types of two-port network and what are the various parameters. So let us start with two-port network. So first question comes to our mind that what is port and why it is called two-port. Basically, a port is a pair of nodes across which a device can be connected. The voltage is measured across the pair of nodes, and the current going onto one node is the same as the current coming out of the other node in pair. These pairs are entry or exit points of the network. That means, port is a pair of nodes across which device can be connected. That is known as port. So here we will see this is the port of a network and this is another port of the network. So in a network with two input terminals and two output terminals is called a port terminal network or two-port network. That means here we have pair of ports, so it is two-port network or port terminal network. It is convenient to develop special methods for the systematic treatment of networks. In the case of a single port linear active network, we obtain the Thevenin equivalent circuit and the Norton equivalent circuit. When a linear passive network is considered, it is convenient to study its behavior related to the pair of designated nodes. In a two-port network, there are two voltage variables and two current variables. And according to the choice of input and output port, these voltage and current variables can be arranged in different equations, giving rise to different port parameters. That means we can easily understand from these words that two-port network is basically communication of the relationship between voltage and current. So there will be two ports where we will indicate the voltage parameters, and there will be also two ports where we will indicate the current parameters. That means, and among this voltage and current there will be a relationship, and based on that relationship that two-port networks are basically will come to what are the types of two-port network. Basically, here we have indicated the types of two-port network. The types of two-port network. So we can see that there are mainly 6 types of two-port network. First one is open circuit impedance parameters, which is called as Z parameters. Second one is short circuit and admittance parameters, which are also called Y parameters. Thirdly, transmission or chain parameters, which are also known as T parameters or ABCD parameters. Fourthly, inverse transmission parameters, that is T inverse parameters. Fifth, hybrid parameters or H parameters. And sixth, inverse hybrid parameters or G parameters. According to MAKAUT syllabus, inverse transmission parameter or T parameters are not included, and also the inverse hybrid parameters, T parameters, are not included in MAKAUT syllabus. That means we will learn about Z parameters, we will learn about Y parameters, then we will learn about ABCD parameters or transmission line parameter or T parameter, and then H parameters. These 4 parameters we will basically learn, which is included in MAKAUT curriculum. Now, first we will start with open circuit impedance parameters or Z parameters. The impedance parameters represents the relation between the voltages and the currents in the two-port network. That is, what is impedance parameters? This is impedance parameters basically represent the voltage and current in the two-port network, that is impedance network. So, in matrix form, impedance parameters can be written as V1, V2 equals to Z11, Z12, Z21, Z22 into I1, I2. That means V equals to Zi. Both the parameters, where Z is the impedance, and we have formed the impedance matrix using Z11, Z12, Z21, Z22. Basically, this is two-port network, so definitely we have 2 voltages V1, V2 and 2 currents, that is I1, I2. And using these relations, we can write that V1 equals to Z11 I1 plus Z12 I2, or V2 equals to Z21 I1 plus Z22 I2. Just multiply using matrix multiplication. So, in this matrix equation, it is easily seen that without even expanding the individual equations, that Z11 equals to V1 by I1, then I2 equals to 0. If we are putting I2 equals to 0 in this equation, if we are putting that I2 equals to 0 in this equation, we will get definitely this one, Z11 equals to V1 by I1 when I2 equals to 0, and this Z11 is known as driving point impedance at port 1. Similarly, if we go to Z12, definitely if we want to calculate Z12 and we are thinking that I1 equals to 0, then definitely we can get the value of Z12, that is V1 by I2, when I1 equals to 0 equals to basically Z12, and that is known as transfer impedance. Similarly, putting I2 equals to 0 in the second equation, we are getting that the value of Z21, then that will be V2 by I1 when I2 equals to 0, and that Z2 is also the transfer impedance. Next, taking I1 equals to 0 in the second equation, we are getting that Z22 equals to V2 by I2 when I1 equals to 0, and that is known as driving point impedance at port 2. It can be seen that the Z parameters correspond to the driving point and transfer impedance at each port, with other port having zero current. Thus, these parameters are also referred to as open circuit parameters. Okay. So, these are basically Z parameters or open circuit parameters, and where Z parameters are indicated by Z11, Z12, Z21 and Z22. Now we will go to short circuit admittance parameters or Y parameters. The admittance parameters represents the relation between the currents and the voltages in the two-port network. So, what is that? Admittance parameters represents the relationship between currents and voltages in two-port network. The admittance parameter matrix may be written as I1, I2 equals to Y11, Y12, Y21, Y22 into P1, V2, or I1 equals to Y11, V1 plus Y12, V2. And similarly, I2 equals to Y21, V1 plus Y22, V2. These are basically admittance parameters which are known as Y parameters. So, similar lines in parameter calculation, we will calculate the Y parameters. And Y parameters are Y11, Y12, Y21 and Y22. So, if we want to calculate Y11, Y12, Y21 or Y22, have to do the same calculations like Z parameters. So, in these two equations, we will put simultaneously V2 equals to 0 and V1 equals to 0 to get the value of Y11 and Y12. So, taking first one, that is putting the value of V2 equals to 0, we are getting I1 by V1 equals to, when V2 equals to 0, we are getting Y11. That is known as driving point admittance at port 1. Similarly, in equation 1, we are putting V1 equals to 0 and we are getting the value of Y12, and that will be equals to I1 by V2 equals to Y12 when V1 equals to 0, and that is known as transfer admittance. Okay. Similarly, in equation 2, we are putting V2 equals to 0 and we are getting the value of Y21, and the value of Y21 is equals to I2 by V1, and that is also known as transfer admittance. Similar line that we are getting Y22 by putting V1 equals to 0 and that is known as driving point admittance at port 2. So it can be seen that the Y parameter corresponds to the driving point and the transfer admittance at each port with the other port having zero voltage, that is short circuit. Thus, these parameters are also referred as short circuit parameters. Okay. So, have you understood that why it is called short circuit? Because we know that when the circuit is shorted, at the time the voltage is zero, and here all the parameter calculation we have done with making the voltage zero, that V1 equals to 0 or V2 equals to 0, like that way. So these parameters are known as short circuit parameters. Now we are going to third point, that is transmission line parameters or ABCD parameters. The ABCD parameters represents the relation between input quantities and output quantities in the two-port network, and they are the voltage current pair. That means ABCD parameter is basically combination of voltage and current pairs. This represents the relation between input quantities and output quantities in the two-port network, and they are thus the voltage current pairs. However, as the quantities are defined as an input-output relation, the output current is marked as going out rather than as coming into the port. The transmitter parameters are written as P1 I1 equals to ABCD into P2 minus I2. The transmission parameters equations are V1 equals to AV2 minus VI2 and I1 equals to CV2 minus VI2. And the parameter ABCD can be defined as similar manner like previous calculations we have made, putting I2 equals to 0 in first equation, we are getting the value of A, which is known as open circuit reverse voltage gain. Why it is called voltage gain? It is because the ratio of voltage input by voltage output. So it is known as gain. So it is open circuit reverse voltage gain. Next, we have to calculate V, and we have say that V equals to minus V1 by I2 when V2 equals to 0. V2 equals to 0 means it is short circuit. So this is short circuit transfer impedance. Now when we are calculating C, we are getting that C equals to I1 by V2 when I2 equals to 0. And I0 means the path is open. So this is open circuit transfer admittance. Okay. V by I, so it is impedance, and this is I by V, so it is admittance. Next, D. D is equals to minus I1 by I2 when V2 equals to 0. Again, it is short circuit. So it is short circuit reverse current gain, because again it is ratio of input current with output current. So it is short circuit reverse current gain. These parameters are basically known as transmission parameters, as in a transmission line, the current enters at one end and leaves at the other end. And we need to know a relation between the sending and quantities and the receiving end quantities. So, these are transmission line parameters or ABCD parameter or P parameter. Fourth one is hybrid parameter or H parameter. The hybrid parameter represents a mixed or hybrid relation between the voltages and the currents in the two-port network. That means hybrid parameter is basically mixed or hybrid relation between voltage and current. So this is known as hybrid parameter. So H parameters are written as V1 I2 equals to H11, H12, H21, H22 into I1 V2. So from here we can form the equation, that is V1 equals to H11 I1 plus H12 V2 and I2 equals to H21 I1 plus H2 V2. Similarly, we can calculate H11, H22, H21, H12, all these things we can calculate similar manner. So we are getting that H11 equals to V1 by I1 when V2 equals to 0, and definitely as this is V2 equals to 0, so this is short circuit, and the relation is between V by I, so it is impedance, and at port 1 because all these relation V and I are in port 1. Second one, that is H12, it is ratio between again V1 by V2 when I1 equals to 0, that means it is open circuit. So it is open circuit reverse voltage gain. Again it is gain because it is ratio between our input voltage and output voltage. Thirdly, H21, it is between I2 by I1 and V2 equals to 0, that means path is shorted, short circuit, and between two currents, so it is current gain. Fourthly, H22 when I2 by V2 and I1 equals to 0, so it will be open circuit, output, admittance. Okay. So as H parameters are dimensionally mixed, they are also named mixed parameters. Transistor circuit models are generally represented by these parameters, and as the input impedance H11 and the short circuit current gain H21 can be easily measured by making the output circuit shorted. So now we will look into a small numerical problem based on Z parameters or open circuit impedance parameters. We can see that we have a network where three resistances are present. Really, these are inductances. J10 ohm, those are inductive reactances. So by applying KVL, that means we are applying KVL in loop 1, this one, and we are again applying KVL in this loop. So applying KVL, we are getting that J10 plus 5 into I1 plus 5I2 equals to V1, and in this loop we are applying KVL, we are getting J15 plus 5I2 plus 5I1 equals to V2. These two equations we are getting, and similar calculation we have made. We have compared this with normal equations of Z parameters like V1 equals to Z11 I1, Z12 I2. Those equations we have compared, and we are getting that the value of Z11 equals to 5 plus J second, and Z12 and Z21 is 5 ohm, and Z22 is 5 plus J15 ohm. These are all the values of open circuit parameters. It is a small problem related to open circuit parameters. Another problem we have considered here: determine the Z parameters for the network shown in the figure. Again, here we are taking that when I1 equals to 0, the port 1 is open circuited. So in this case, no current will flow through the 5 ohm. So at that case, our equation becomes like this, and we are getting the value of Z22 equals to 30 ohm. Similarly, we are getting Z12 value when I1 equals to 0, and we are getting that V1 by I2 equals to 20 ohm and I1 equals to 0. So, in that way, we can determine the parameters of Z or open circuit parameters. And Z11 parameter we can also determine, like previously we have determined those parameters. So, similarly, we can calculate those parameters. So, value of Z12 and Z21 is same, and Z22 we have calculated that V2 by I2 equals to 30 ohm. And similar way we can calculate the value of Z11 using same formula like the previous problem. So not much more today. So thank you all for listening this lecture. This is the introductory lecture of spoke network, and we have discussed about all parameters like open circuit parameter, short circuit parameters, ABCD parameter, and H parameter. And why these parameters are known as open circuit or short circuit or ABCD, they will have discussed. And these lectures we have taken from the book of Basics of Electrical Circuit Theory. You can go to that book for understanding this chapter. And other books you can also follow that circuit theory by studying circuit theory by studying book you can also take it. Definitely this 4 parameters we have considered here based on Markov criteria. And 2 parameters we have both. Those are not included in the theory. So thank you all. Thanks for listening.